guys, it's Mrs. Jackson going to give you a video answer key today over the practice problems you completed last week on predicting the products for the single replacement and double replacement reactions. So what you're going to need as you go through this video is going to be your periodic table that has the ions on the back. You're going to need your practice set, your thinking cap, and in this case, I don't think you're going to need your calculator. So be sure that before you move on in the video, you've got your periodic table with ions ready to look at, your practice problems, and be ready to go. All right, so the first couple of problems on your practice set, the first one was zinc metal reacts with lead 2 acetate, and you've got two products that form. So the first thing that you were supposed to do was identify the type of reaction. And because I have a single element located right here and an ionic compound, I know that this is going to be a single replacement reaction. And when I have a single replacement reaction, I have to look at my element that is single or by itself, and I have to determine if that element is a metal or a halogen, and in this case zinc is a metal. So what I do when I compare my two elements, zinc is a metal and lead is a metal, so I'm comparing those two because the least reactive always ends up alone. So now that I'm looking at my two metals, lead and zinc, I have to access my activity series of metals. That's what we have right here. This is our activity series of metals. You have this on your reaction cheat sheet, and I need to compare the reactivity of zinc to lead. So when I look at my activity series, here is zinc, and lead is down here below zinc. So when I look at the two, zinc is higher, which means he is more reactive, so he will replace lead. Lead is lower and less reactive, so he winds up alone. Always write the element that winds up alone by itself first. So there's my lead. I don't need a charge because it's going to be all by itself. Then in the blank, okay, I need to write my chemical formula for the compound. I've got zinc, and this ion right here, C2H3O2, is called acetate. And when you look it up on your chart, it's right here, it's at the top. When you look that up, it has a -1 charge. So C2H3O2 has a -1 charge. And when I look up zinc down here, zinc is down here. I know you can't read this, but look on your own chart. Zinc is right here, and it has a 2+ charge. So I'm going to have to crisscross a +2 and a -1. So I'm going to need parentheses around the acetate ion. I crisscross a 1 down here, and I crisscross the 2 outside, just like we've done for weeks and weeks. And I have Zn parentheses C2H3O2, and then I have that crisscross 2 outside the parentheses. So if you need to review that or watch it again, please pause the video, review it, okay, rewind it just a hair, and watch that explanation one more time. Moving on to the next problem, I have ammonium hydroxide here and hydrochloric acid here. So this is going to be not a single replacement, but a double replacement. Because I don't have an element by itself, there's no single element here, and I have two ionic compounds, I'm going to have a split and switch double replacement. So when you look up your ions, ammonium is NH4, and it is located right here, right in the middle of your periodic table. And that ammonium is going to split from the hydroxide, and the hydrogen is going to split from the chlorine. So when I look up my charges, I need to rewrite my compounds for my other side. Remember that the outsides are going to go together, and my insides are going to go together. And I'm always going to list the positive ion first. So for my first compound, I'm going to take over the NH4. So I'm going to have NH4 here. I'm going to make this a little bit smaller, so we've got a little bit more space. So under the first blank, I'm going to write my NH4 on your chart. You can look it up. It has a +1 charge. And then I'm going to write the chloride because that's the outsides. Those are my two outsides. I've got a +1 and a -1, so my formula is going to be NH4Cl, ammonium chloride. And for the second blank, I'm going to bring over my other two ions. Now I'm going to bring over hydrogen first because it's positive. So I've got hydrogen here. Its charge is a +1. And then I'm going to bring over my hydroxide, OH, and it is a -1. You can write this answer as HOH if you would like to, or you can write it in its more common form, H2O. That's the first two practice problems. Okay. Moving on to numbers 3 and 4. When I look at my reaction for number 3, I have two ionic compounds. Ionic compounds are metal plus nonmetal. And I have hydrogen and a nonmetal. So this is a double replacement. So I'm going to split the metal off of the front. I break the ions apart. Okay. And I'm going to split and switch the ions. So my outsides are going to go together again, and the insides are going to go together again. So when I write my ions on the other side, I've got calcium. When I write calcium, I come down to the bottom, I look it up. Calcium's right here, and it is a +2. So I write my calcium formula, calcium with a 2+ charge. And then I look for sulfur. Sulfur's right here. When I look on the periodic table, sulfur is located way over here. So you can find its charge. Sulfur is a -2 charge. So I've got S with a 2-. So when I crisscross those two charges, I bring a 2 down, and I want to bring my 2 down. I normally might have Ca2S2, but because my 2's, because each of those subscripts is a 2, that will reduce. And so my formula will be simply CaS. I reduce the 2's to 1's. For the second compound, I find my hydrogen. I don't bring the 2, I just bring the hydrogen and look up its charge. When I look at the charge down here for hydrogen, I've got the +1. And then I've got oxygen. Oxygen is the other inside ion that I'm going to use. So my oxygen is right here. When I look up the charge for oxygen, it is a 2-. My oxide ion is located right down here just ahead of the sulfur. When I crisscross those values, I wind up with H2O as my second compound. All right, number 4. Number 4 has an element by itself. So now that I've got this lithium by itself, I know that this is going to be a single replacement reaction and not a double replacement reaction. The next thing that I look at is the water. I've got water here, and I told you in the instructional video how to approach water if you have it in a chemical reaction, in a replacement reaction. And that is to write the formula as HOH, because the hydrogens don't stay together on this one. So when I look at my compounds that I have, all right, I've got lithium by itself and I've got hydrogen. Well, because this is single replacement, I need to compare the reactivity of lithium to hydrogen. The one that is least reactive winds up alone. So when I look at my chart, I've got lithium not listed on this particular one, but it's going to be up here with potassium and sodium. So your lithium is right up in here. The other one that you're looking at is your hydrogen, who is very low on the reactivity series. So hydrogen is going to end up by itself. So hydrogen winds up alone. When I write hydrogen by itself, okay, he's one of those 7 Brinkelhoff elements. He cannot stay by himself. He always has his 2 when he's alone. So he's an H2. In my second blank, I have a compound. So to write my compound, I bring over my ions. I'm going to have lithium doing the replacing of hydrogen. When I look that up, it's located right here on your paper. It is a +1 charge, and that leaves me with the other ion, OH. When I look up OH, OH is over here on your hydroxide or your -1 chart. He's right here. And so hydroxide is OH with a -1. When I crisscross reduce, I wind up with LiOH as my product. I think that's probably the most tricky one on the homework set. So if you got that one right, be very proud of yourself. That's an awesome job. All right, number 5 and 6. Again, I have an element that is by itself. Okay, so when I see my element by itself, I know that this is going to be a single replacement reaction. So then I need to look at what's in the metal place in my compound, and it is hydrogen. So I want to come over and look at my activity series of metals, and barium isn't located on this one. I apologize. I thought I grabbed the right series. Barium is going to be right in this area. So this is where barium is, and hydrogen's at the bottom. So hydrogen's way down here. So hydrogen again ends up alone. So hydrogen, when he's by himself, winds up as H2. And now I've got barium that's going to go into compound with a 2+ charge. And I've got the SO4, which is a sulfate ion with a 2-. Because those charges are the same, 2+, 2-, I crisscross reduce, and my chemical formula is BaSO4. And that's my final answer on that one. Number 6, okay, I have 2 compounds. I've got aluminum bromide and potassium sulfate. So these are 2 ionic compounds. So this one is going to be a double replacement reaction. So we're going to split and switch, and the outsides are going to go together and the insides are going to go together. So when I split them, I split the aluminum off of the bromine, and I split the potassium from the sulfur. So for my outsides that are going to go together, let me shrink our table just a hair. So for the outsides that are going to go together, I'm going to have aluminum, and I'm going to have sulfate. Now sulfate is the whole ion, SO4. When you look on your ion chart down here at the bottom, sulfate is located in this box, the -2 box. And so sulfate is right here. That's going to be your sulfate. And when we write sulfate, SO4, okay, and when I look at my charge, it's a 2-. When I look for the charge of aluminum, aluminum is right here on your chart, and it's going to be a 3+. So I put parentheses around my polyatomic ion like we've worked on for months, and then I'm going to crisscross. My 2 comes down, and the 3 goes down here, and my final answer will be Al2, SO4, wrap it in parentheses, and that 3 is outside. So that's the first blank. The second blank is going to be my insides go together. So potassium is written first because it's positive, and then I have bromine written second. Now notice I didn't bring over the 3 that's located on the bromine. This 3 did not come with it. That's because the bromines all break apart. Bromine, when he goes into compound, he breaks apart. The reason that the 4 came over with the sulfate is because that's part of the formula when you look in your box right here. When you look at bromine in its box right here, it's just Br by itself. Same is true for potassium. Potassium is here on your chart, and it's only a potassium by itself with a +1 charge. When I crisscross reduce, I wind up with KBr. Those are my two products for that particular reaction. For number 7 and 8, again, I am working with a double replacement reaction. I've got two ionic compounds. I've got a silver nitrate and magnesium chloride. So these are two ionic compounds that are going to split and switch. So I'm going to split the aluminum from the nitrate. And nitrate is one of those polyatomic ions. That big ion all works together. And then I'm going to split the magnesium from the chlorine. So again, my outsides are going to go together and the insides are going to go together. So when I write my outsides, I've got silver. And when I look down below, silver's right here on your periodic table. He's going to be a +1. And then I've got to look up chloride. So chlorine is the other one it's going to bond to, and chlorine is right here. So again, I'm not going to bring this 2 with me. When I look in this box on my periodic table, when I look at that box, it tells me what the ion should look like. And the ion here should just look like Cl by itself. So I bring over the chlorine, and it's a -1 charge. When I crisscross reduce, my formula will be AgCl. That's silver chloride. Now I need to partner my insides. So the magnesium is here. When I write magnesium, right there, and I come down to the bottom to find its charge, magnesium is right here with a 2+ charge. So magnesium gets a 2+. And then I have to come over and look at this nitrate. Right here, nitrate is NO3. When I look up NO3 on my chart, nitrate is going to be right here on your ion chart. So that N and the O and the 3 all come over together. That's what the ion looks like from my table. That NO3 comes together and it has a -1 charge. So when I crisscross reduce, I'm going to have to put my parentheses around nitrate like we've always done. I bring a 1 down here and I'll bring the 2 outside. And I wind up with Mg, and then my parentheses, NO3, parentheses, and a 2. And those would be your 2 final formulas. Now, if you've got the same formula, but you have them in different blanks, so if you listed magnesium nitrate first and silver chloride second, that is okay. For all of the reactions we've done so far, that would be acceptable. But the positive metal has to be in front and the negative anion has to be at the end. For number 8, similar. Another double replacement reaction because I've got 2 ionic compounds, so this one is double replacement. I'm going to split and switch. So I split that apart and I split this apart. And I'm going to partner the outsides and the insides. When I look at this iron, I've got iron right here, but I've got more than one choice down in my box. Iron is right here, and there's 3 choices. So I've got to look at my compound, and I do my uncross. I bring the 3 up, and I bring the understood 1 up. It looks like it's going to be iron with a 3 charge and chlorine with a -1. Just like we did when we named compounds, I want to double check the charge on this negative ion. So chlorine is way over here. When I check it, chlorine does have the -1, and so that means iron is really a +3. So over here, I've got iron with a 3 charge, and I look up OH. OH is located right here, and OH is a -1 charge. So when I crisscross reduce, Fe, parentheses, OH, close parentheses, and the 3 goes outside. Any of your polyatomic ions have to have those parentheses around them. I do the same for sodium and chlorine. Sodium is a +1, chlorine is a -1. So NaCl is the second compound that you form. The final 2, this first one is I have a magnesium by itself, and I have a compound next to it. So this one, because I've got a metal and a compound with a metal, this is going to be an example of a single replacement reaction. So I need to check and compare magnesium and aluminum to see who is the least reactive and ends up alone. So when I come over here, magnesium is located here, and aluminum on this chart is right below it. So aluminum is the least reactive, so aluminum ends up alone. So I just write Al. He is not part of that special group of atoms that get the 2s. Remember, that's Brinkelhoff: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. So I just leave him as an Al. He's all by himself, and that's all he gets. And then I've got to write my compound formula. So magnesium, when I check down below, is a 2+ charge right here. So magnesium gets the 2 charge. And then I look for nitrate. Nitrate is NO3. Nitrate is located in my -1 box. He's located right here. And because he is written as NO3 in my box, he is written as NO3 here, and his charge is -1. So when I crisscross reduce, I wind up with Mg, NO3, and that 2 goes outside the parentheses. The final example is a single replacement halogen. So this is just a little bit different. So if this one gave you trouble, it's probably the second most difficult one on the chart. So there is my lone element, and it is bromine. And bromine is not a metal. Bromine is located over here on the halogen list. So he's one of our halogens over here on this column number 7. And really made a mess of that. So when I look at bromine and I want to know if this reaction is going to happen, because bromine is a halogen, I need to replace the other halogen. Well, sodium is over here. He's a metal. So I'm comparing bromine to the other halogen, iodine. Both of those elements are located over here. Here's bromine and here's iodine. And just like the activity series of metals, the element at the bottom is least reactive, and the element that's higher on the list is most reactive. So iodine right here is the least reactive, and he's going to end up by himself. Iodine is part of Brinkelhoff, so he gets his I2. And then I've got to partner sodium and bromine. Well, sodium has to go in the front because it's a metal. He's a +1 charge. He's located right here. And then I'm going to bring over the bromine. And when I look bromine up, bromine is right here, but he's just a Br, so I don't bring the 2 with him. Okay? Because he's not written as Br2 in his box, he's written as only Br. I write only Br on the right-hand side. -1 charge, so when I crisscross, I get Na, Br. And that's my final product. None of these reactions are balanced. We focused on just simply writing the compounds in the blanks. So go back through, watch the video again if you need to see any example worked again. Don't hesitate to reach out with questions if you have them. Thanks, and I'll see you soon. Bye.